Tring, tring.
Hello.
Hello, Kanika. I am Tarun calling from ABC Company. I have a proposal to discuss. Do you have time to talk?
Yeah, Tarun, please go ahead.
Okay, I want to do a study in which we want to take the experience of MRSI attendees today who have come by their own private jets. But my incentive cost, I have budget of rupees 500 rupees per respondent. Can you make it happen?
Absolutely, Tarun. Totally feasible. Just tell me when to start.
Kanika, what are you saying? This is nowhere near feasible. And making such promises makes our entire industry lose credibility, and this is exactly why the survey data is losing trust.
Don't worry, we'll manage somehow.
This act was imagery, but what if it was real? We all know a recent $10 million fraud that happened. If we continue to see such cases, then client will lose their trust in online data collection. We all see that we spend a lot of efforts in doing data cleaning, finding bad respondents, but still there are some noises which remains in your data collection for your data strategy. So now with this initiative or with this presentation, we want to come forward to find a benchmarking which can rate the respondents based on the answers which they are providing. And this is the reason we have to come forward so that like clients have started to go towards synthetic data. Last 2 years there have been a lot of research going on synthetic data. So we have to regain the trust in online research data collection. So let's proceed on that.
Absolutely, Tarun. But before we deal with them, we must know who we are dealing with. So there are three main types of enemies that we have to deal with. First is the tech fraud. These are the bots and AI agents, and they carry the capacity to flood our survey response data by thousands of responses within minutes. Then we have the human fraud. These are professional fraudsters, of course with wrong intentions, who work with tools like multiple IDs, VPNs, and other clever tricks so that they can grab more incentives. And now this one is a silent culprit, where these are the actual respondents that we deal with, but they don't really mean any harm. They just straight line, they rush through the responses, or they are just inattentive and careless during the survey, while taking the survey. But their disengagement can cost us heavily given the dilution that they can cause to the signals. They all give us different kind of threats, hence there is no single silver bullet that can dodge all of them. Hence we created a guardian shield that has multiple layers and that does not just react but anticipates, adapts and evolve with the fight for fighting fraud across the survey journey. Think of this like airport security, how one check is for the ID, another one is for the baggage, another one is for the body scan. All of them are looking for a different kind of threat. So our survey architecture also works in a very similar way. So even if the fraud pass through one layer, it's not able to go too far. Let's see how these shields looks like. First we check the digital passport of the respondent before they even enter the survey. Then we see if the respondent is engaged enough throughout the survey to see if they were reading or if they were speeding. Then we have within the survey logic traps, memory challenges, memory recalls and other kind of traps wherein a genuine respondent would pass but a bot or a bad respondent, a speedster, would fail these checks. In the LLM evaluation, we check for the open-end responses, and here the AI scans for the completeness, relevance, copy-paste detection, tab switching, in fact, gibberish and duplicacy also of responses. And the final audit room is for the post-survey validation, where we have the multi-rule based checks as well. Though all of this looks very strong, it is very strong. However, given the way the threat is evolving day by day, we need to have the power of and for our shield, the power of and is an additional armor that our shield learns. We call this the learning loop. Here, every time we misclassify a respondent, either by letting a fraudster slip through or by wrongly flagging a genuine respondent. That information is fed back into the AI model so that we are better prepared for the next time's frauds. The scoring system is dual. First, we calculate the individual shield score, wherein we get to know whether the respondent passed the security, whether they were engaged enough, if they were attentive, or if their open ends made sense. Using this individual shield score, we calculate a Guardian score, which is a composite sum of the individual shields that we calculated earlier, and this gives us a single number that tells us if we can trust that respondent. Now, since we have the Guardian score, now we can classify these respondents not just as binary pass or fail, but as per the zones of trust, if we can trust them with confidence, if we need to be cautious, or if we need to exclude them completely. And this changes our question from whether data fraud happened or not to how much integrity does this data have and where. Because practically speaking, there is no one-size-fits-all solution for to dodge all kind of frauds, because any kind of benchmarking that we are dealing with has to be flexible enough to shift with the context. Let's take an example. In open ends, let's say, there are certain cultures where people naturally talk less. So in that case, their short responses cannot be considered as a bad response. It's just that they are different. That is why this algorithm that we have developed, this is absolutely flexible, completely customizable, which balances the consistency and the shifts that we need with the benchmarking. In this case, I'm talking about the cultural nuance, which also balances the data reliability and along with the context relevance.
So enough of theory now. Now it's a time where we talk about when we implemented these guardians, then how these were able to find frauds. So we implemented this algorithm in one of the 50-minute survey, which was on fast food across the respondents in India. There were total 57 metrics on which we rated the respondents to find out the quality. And the data was collected from multiple panels, email campaign and other campaigns, so that we can compare the quality of different mediums as well. So now let's see what are the results that we got from it. So you have seen this, all these shields from the previous slides. The bottom scores tells that how much respondents were flagged in each of the fields. So we can clearly see that 2% of the respondents were stopped even taking the surveys in the first exercise. And majority of the people were flagged in the LLM evaluation. Whether it's a researcher, whether it's a respondent, they hate having the open-end question. But I must say that open-end question is a very good question to check whether there is an actual respondent fraud or a human fraud. So we categorize the respondents into 3 categories using benchmarks. We can find out whether the persons are trusted, non-trusted, or watch list. But the good thing is that since we are having a learning loop, so we can find after each study whether there are any false negatives or false positives, or maybe there is any learning that we get from the study that can be fed into the learning system for the future. Now this is the slide which talks a lot. Why? Because after all these hard work by these guardians, there were 73% valid completes. That means in this study, we were able to find 20% respondents which were not usable in that study. What happens in the journal studies, we find like 5 to 10% bad respondents, but there are certain respondents which stays in your data for strategy, but those are actually noise, not the actual respondents. But having this shield, if you see the next slide, sorry, please, just a second. Yeah. So when you further categorize those 27% into these different frauds we were talking about, we will see it's not just the tech fraud that is happening. There is some human fraud along with the bad respondents. That means every fraud, every kind of fraud has to be taken care specifically. Now, when you compare the results of having the survey without the shield and with the shield, we can clearly see that there is a 2.5 times more cleaning that happened. So in the traditional way, we are getting 89% usable completes, but in the with shields, we are getting 73%. So we are finding more noises while we are using multiple layer algorithms. So now, having these algorithms, what's in for us? Of course, it will save a lot of time, cost, and efforts, both from the data collection partners and the researchers, which do a lot of work while doing the cleaning and finding the bad respondents after the fieldwork is done. And of course, when we have a strong benchmarking and algorithm like this, then we are assured that we are dealing with reliable and dependable data for the strategy that we are making. And of course, an opportunity. And what's an opportunity is, right now we are dealing with different kind of benchmarking, different kind of methods to find bad respondents. So we can lead this in MRSI known as like a leading research community in India can lead this initiative with the help of all the people in this community to make a standard algorithm which can be tested here and can be used globally. To end this presentation, I would just like to highlight that this is not an or. Standalone, we cannot do it, or maybe any other organization cannot do it. So we all have to come together. Researchers have to make surveys clean and crisp, and we have to apply such algorithm where the data cleaning is happening at runtime. So it will be a collective effort, and everyone has to come forward to make it happen. Thank you so much.
Thank you very much. First question, with bots now trained to mimic human-like response patterns, what signals or techniques do you see as most effective in reliably identifying them?
So you're asking how to identify whether they are bots.
What are the patterns?
Right, so there can be multiple ways you can find bots, and I would not go into technical, but will cite a few examples. Like whenever we are doing a study which involves some exercises like concept tests or virtual self-test, we can find mouse tracking. You'll find the humans are like making some mouse movements to make some selections. But in case of bots, it will be like very, very random. And when you talk about open ends, we capture like what is the typing speed of how the responses are entered, whether it is copy-pasted from the sources or not. So you will find the pattern switch between the actual human and the bots. So these are some of the signals.
Thank you. So we saw that globally it's around 30 to 40% is data fraud, and in our survey, what you did, it's 27%. What are the things we can do to take care of the input of the respondents inside the system to avoid these things? Recruiting. How can you control the recruiting of respondents into the panel or the survey to avoid these data frauds? Is there any way? Okay. So we have around 30% of data frauds in the 27% in this one. Globally, 30 to 40%. Is there a way to avoid this by perfecting the recruiting system? How we get the panel lists?
Recruiting system of panels.
Panels, yeah.
Okay, so I mean, when you rate, so basically in this algorithm, we are rating the respondents on the basis of the quality. But if in case we are doing a study with multiple partners involved, so what we can do is, with this algorithm, we can have a benchmark for the panel scoring as well. So when you are rating the respondents from different panels, there can be a benchmarking done that if I'm doing a study with multiple partners, what was the average score that was coming out from each panel? And then subsequently, we can give feedbacks to those panel that we are finding some noises and we are finding some frauds from it. And it's a duty of the providers to frequently check their databases and do some kind of cleaning so that that does not happen again. So,
thank you.
Also, there are steps like when some survey link is online for a very long period of time. So that is a very inviting thing for bots and for human fraud, that this is a very easy gate to get in, and that's where they use multiple IDs and they do the fraud. It's like, okay, this window is open and the signal is flagged and we get more responses suddenly. So whenever we are having some link in the field, so if that link is supposed to stay in the field for a very long time, so then frequently we should keep changing the link for the survey.
Yeah. Thank you. Thanks a lot.
Thank you.